So the next 2 pages are some old STAR test questions that are about the transformations. Now these are the easier ones where they give you both equations. You can see this one here is the y equals x squared, that's the parent. And then this is the new one. They're always going to let the parent, they're always going to compare it to the parent. So the parent will always be your first one, and this will be the second one. You have to know which one's the original and which is the new one, so you know whether to say the new one moved up or did the new one move down. If you reverse which is first and which is second, then instead of saying it went up 3, you would say it went down 3. So this is always the first one. So whenever you see the parent function, you might want to put a little 1 next to it. It's the original. So when you type it in the equation, doesn't matter whether they give it to you first or second, it's the first one. And you'll see what I mean by that in just a second. It's the original. This is the new one. So the good news is these are so easy that all you do is type them in the calculator and just look at the picture and then answer the question. Okay? The choices are translate the graph of f of x 6 units to the right. Now, f of x is the original one. So this is the first one you put in. And they want to know when you put the new one in, did the new one move 6 units to the left? So all you got to do is type this one in and see what happens, okay? And then same thing here, it's saying f of x is the original one. It's saying that you're translating the original one 6 units to the right. So you put this one in first, then you put the new one in, and did the new one go 6 units to the right? That's what they're asking. This one's saying that the original one is moving 6 units up. And this one is saying that you're going to translate. Remember, translate's the fancy word for slide or shift. Translate the graph 6 units down. So the question is it 6 units left, 6 units right, 6 units up, or 6 units down? And of course, you can see the 6 in there. So if you go put it in the calculator, you'll see what it did. Remember, that's the first one. This is the second one. So I'm going to pause the video. You can pause the video and go put both of them in the calculator and see what changed. Okay, hopefully you went and did that. Now, if you remember from the poster, this number on the end, or actually just from our general knowledge, this is our y-intercept. This one has a y-intercept of 0. This one has a y-intercept of -6. So instead of crossing the y-axis at 0, it's crossing at -6. So is the new one further up on the y-axis or further down on the y-axis? Yes, it is further down on the y-axis. So changing a number out here on the end, because it's always 0 to start with, because we're only going to compare them to the parent function this year. That one's at 0, so this one is -6, which means it went down 6 units. It went straight down the y-axis 6 units, so this is the one we're looking for. And again, you don't have to know that shortcut. You can just put them in the calculator and look at the picture and see what happens. So that's why these are actually really easy STAR test questions, because they give you the equations. So here's another one. How does the graph g of x equals x squared plus 1.5 differ from the graph of the function f of x equals x squared? Again, this is the parent function. See, they gave it to you second, but it's still the first one. It's the original one. How did this one change from that one? So put it in, and it doesn't matter what order you put them in as long as you know that that is the original one. Okay, so there's my original one. This is the new one. Okay, now it's either going to be 1.5 units up, 1.5 units down, 1.5 units to the left, or 1.5 to the right. So all you got to do is put this one in first, put that one in, and see where this new one went. Did it go up? Did it go down? Did it go right or to the left of the original one? So go do that if you haven't already done it. Okay, hopefully you pause the video and you're coming back. Now, if you remember, this one here has a y-intercept of 0, plus 0's out here, right? My y-intercept is 0, it's crossing at 0. Where is this one going to cross at? 1.5 on the y-axis. So 0 compared to 1.5 on the y-axis, remember 0 is in the middle and 1.5 is up 1.5 units. So which way did it go? It went up 1.5 units. And again, you don't have to remember the fancy shortcuts. You can just put them in the calculator and look at the picture. That's why these are the easy versions. Tomorrow we're going to do the harder versions where they don't give you the 2 equations, and those you have to know the notes, kind of shorthand stuff, and those you just have to memorize. And if you don't memorize them, there's only going to be maybe 1, at the most maybe 2 questions that are not where they give them. So they only do a few transformations, and then maybe 3 or 4 transformations, and between the quadratic and the linears. And out of those, maybe only 1 or 2 would be the harder version. So anyway, if you miss 1 or 2, you're still not going to keep you from passing. It's not going to keep you from making commended. You can still miss, I think, 4 or 5 questions on the STAR test and still get commended, which is like making an A. Okay, so this one says, quadratic function q and z are graphed on the same coordinate grid. So I've got 2 different functions. I got an equation q and I got an equation z. The vertex of the graph of q is 7 units below the vertex of the graph of z. Now, if you look at the 2 equations down here, one of them is the parent function, okay? So they give you 2 answers, so we can literally go graph each of these and see which one matches this picture. I would highly recommend that you sketch what this is going to look like before you go put them in the calculator. The vertex of Q is 7 units below. So Q, I'm going to write this as Q. Q is below the other one. Okay, it went 7 units down. Okay, so Q is 7 units down. That means the other one is Z. And it's saying Q is 7 units below the vertex of Z. So what it did was just shifted straight down. So Q is below Z. This is the picture it should make. So when I put these in the calculator, Q should be on bottom and Z should be on top. That's what it should look like, all right? So it should be directly above each other. And it's the Z that needs to be on top, not the Q. So that's why I say make a little sketch here. And then when you put these in the calculator, just compare them. Which one looks like this picture? Just make sure you know which one is Z and Q when you put it in. All right? So go pause the video, go try it out and see what you get. Okay, so hopefully you come back and try the first two to see what happened. The vertex did not change. They were in the exact same location, but this one got skinnier. This one did shift down. You can tell because this was +0, and this one was down 7, so it did shift down 7 units. This one shifted up 7 units, and this one was negative, which meant it flipped over the x-axis. So this was the original one, and the new one flipped over and got really, really skinny. So anytime it's a negative sign, it's going to be flipped over the x-axis. Instead of being a smiley face, it became a frowny face. And then, of course, the 7 made it skinnier. Okay, so anyway, but you can just put it in the calculator and see what matches the little description of what they did, and that's why I make the little picture of what it's supposed to do. So be about answer on that one. If you haven't done one on your own, pause the video. Again, make a little picture here of what P and V look like, and then go find the pair of equations that matches that picture. Okay, so hopefully you have gone and paused the video. And it says the vertex of P is 4 units above. So P is above the other one. Okay, so P is above. And it's straight up. And this is V. So when I get ready to do it in the calculator, V is going to be below and P is going to be up. And P should be 4 units up. And here's my V's. These are the original one, right? These are my parent functions. And I'm looking for the one that went up 4 units. So you could just plug each pair in and see which one matches this picture. Should be straight up above it. V should be on bottom, P should be on top. And if you look at the shortcuts, if you wanted to see if you could figure out that way, that one flipped over the x-axis because it's now negative. It's a frowny face instead of a smiley face. All of these were smiley faces, right? The original parent function, you should always know what that one looks like. This one went up 4 units, that one went down 4 units, so it was H. P was 4 units above. Okay, so you're starting to get the pattern here. They give you 2 equations, put them in the calculator, look at the picture, see if it matches what they say it's going to do. How does the graph of the function h of x, now this one there's a typo in this one. How does the graph of the function h of x equals 3x squared differ from the graph of the parent quadratic? Here's my parent quadratic, it's f. So they talk about f in here, but they talk about g, but they labeled it h. So this g is actually h. They just mislabeled it in here. They typed a g instead of an h. So h is the new one. All right, h is the new one. Now, we did not change the y-intercept, so it did not shift up or down. It stayed positive, so it didn't flip over the x-axis. What did happen, though, was this number in front got bigger. So instead of making it wider, which is what we think it's doing, it actually makes it skinnier. So it stays exactly where it is, except it got skinnier. So the graph of h is narrower than the graph of f is the one we're looking at. And again, you just put them both in the calculator and just look at the picture. This was the first one. So if you were to graph this and look at it, the first one looks something like this. This was f, all right? And then when you put in this one, the vertex was still in the exact same place, except this new one was skinnier, and this one was h. So h was skinnier, or more narrow, or narrower than f. Okay, f was wider, h was narrower. All right, so there was that one. How does the graph of the function h, and again, if you have not done some of these, pause the video and go do them, and then come check your answers. How does the graph of the function h of x, and this one's got stuff done to it, it's negative, which means it flipped over the x-axis, it's now a frowny face, and this is smaller than 1.8, so it got wider. Different from the graph of the function f of x. This is your parent function, right? This is the first one, this is the new one. And they did use f and h's in here. So they want to know, the graph of h, the new one, is narrower, or is it wider? Is it 8 point units below? Did it shift down, or did it shift up? Now, what they did not talk about was the negative sign. They should have said, in addition to that, it was also a reflection over, if I can write, let's pretend that's over, over, the x-axis. So they should have said on each one of these, it's a reflection over the x-axis, reflection over the x-axis, Or on some of the wrong ones, they could have said reflection over the y-axis. We're not flipping it over the y-axis, we're flipping it over the x-axis. And so instead of being a smiley face, it's now a frowny face. So they didn't say that though, but what we do know for sure is that it should have gotten wider because the 0.8 is wider. And the one that did that, and what the picture looked like on this one, just so you can see. The original one was here, right? Okay, here's my original one. Pretend that was a parent function. So that was this one, number 1, looked like that. The new one, when you put in, it was, vertex was still in the same place, but it was flipped over the x-axis because that's what the negative sign does. And then the 0.8 made it wider than the original one. Okay, so it was wider, so we're looking for this one. So even if they didn't give you the part about the reflection of the x-axis, it definitely was wider. You wouldn't pick it was higher or below, above or below, and you definitely wouldn't pick that it was narrower. So you got to make sure you know which one was the original, which one is the new one. Okay, so there's that page. Again, pause the video, go try the other ones and see how you do. There's only 2 more to go. 13, you have 4 different pictures. And then they have 2 equations up here. They just want to know when you put the 2 equations in the calculator, which one looks like these pictures. So again, you're just matching pictures up. That's why these are the easy ones. This is the parent one, and they say the parent is shown as referenced in dash. So this is y equals x squared. That is that one. This is the y equals x squared. This is the parent function, y equals x squared. And again, the dash one is y equals x squared. So those are the parent ones that we're always comparing it to. This is the new one. Now this one has a positive number, so it's a smiley face. Does this one have a positive number? No, it's a frowny face. So my new one should be a frowny face. Frowny face, yes. Frowny face, yes. Frowny face, nope. This one was another smiley face, so get rid of it. Another smiley face, so get rid of it. So one of these 2 pictures is going to match. So either the new one is wider than the original one, or it got skinnier. Okay, so again, just put it in the calculator and look at the picture. If you know your shortcuts, 1/4 makes it wider. You think a smaller number is going to make it skinnier and smaller, but it doesn't. It does just the opposite. It makes it wider. So A was the right one. And if you just put them in the calculator, you can see that. Same thing here, 4 pictures, 2 equations. You're just matching the picture up. This, again, is the parent function, so y equals x squared is that one. They told you let's get the dash one in here. It's for reference. So parent function, parent function, parent function. New one, let's see. This one has a smiley face because my parent function's got a positive 1 there. This one also is a positive number, so they're both going to be smiley faces. So it is not F and it is not G. It's going to be one of these 2. Either the new one is wider or the new one is skinnier. How did my number change? It went from a 1 to a 3. Once the number gets bigger, the parabola gets skinnier. You think it's going to get wider, but it doesn't. It actually does the opposite. It gets skinnier. So my new one is skinnier, and again, you could just put them in the calculator and look at the picture. So which one of these is skinnier than the dash? Remember, it's the first one. This one's wider. This one is the skinnier one, so it is J. There you go. These are the easy versions. These are easy peasy on the STAR test. No reason you should ever miss them as long as you type carefully. And remember, the parent is always the first one, and we're looking to see what changed with the new one. Okay, see you tomorrow.